How's it going, everyone? It's another wonderful day to write some code. We are back today working on the MSP430 disassembler that we started yesterday. This is an attempt to build one in Rust that is a standalone library, something that we can embed into other things. Most notably, the goal is to put it into Binary Ninja to add architecture support for it. Yesterday, we got a beginning implementation going. We got jump-based instructions decoding and parsing. Those seemed to be the easiest to start with. Today, I think we're going to start or move on to the single operand arithmetic instructions. These are things like bit shifts, pushes, calls, ret, I think. Ret I. I can pull up the full list shortly. We're also going to have to do a little bit of refactoring, and I learned a little bit about Binary Ninja yesterday in terms of the APIs that are provided. Actually, let me switch over to the view with the code. So I learned a few things yesterday. Like I said, one of them is what the callbacks look like for instruction decoding. So what Binary Ninja expects is that we expose some kind of function that will take in a pointer to like the data, so it's probably like a uint 8 or something like that, and an address. So it gives you an address and a pointer to the data, and then you go to that position, which is just some basic pointer arithmetic, and you decode at that point. So for right now, this is fine. But this whole idea of using a reader here, or read, probably is not going to be super useful for our use case here. We may end up wanting to keep that function because it may be useful for someone else. But I think that we'll probably end up redesigning some of the APIs by the time we get to the point where we can do the full decoding. One of the other big pieces we're going to have to change today is rather than returning an option jump instruction, we are going to return an option instruction, and we are going to redefine what our instruction type is to be an enum with either a jump or a single operand or two operand is what I believe the types are. Let's pull it up real quick. Instructions, encoding. I think that's what I want. So I think we're going to end up doing these today because I think they'll be a little bit easier. I'm not sure if any of these are 3 bytes or not. They might just be 2. Some of these definitely are 3 or possibly 4 bytes. So I just think it'll be a little bit easier to start with one operand, so we don't have to do as much crazy parsing. I think it's also easier to handle the work here. So let's dive into this. The first thing we're gonna do is we're gonna update this type, and this is gonna be an enum, and it's going to be either a jump. What's the type? single operand. All right. So and then we're going to have to build our... This code's a mess right now. We're going to leave it as a mess. We'll clean stuff up later. So I don't know what's going to be in here yet. We're going to have to figure that out in a little bit. But what I am going to do is go down to here, and we're going to return a instruction here. So this is going to end up failing. Instruction. So we should be able to rerun all of our tests right now, and this should just all succeed. But we didn't... We gotta derive some stuff. Debug, clone. We might also need partial EQ. And we have to then pull that out. Is this going to be the easiest way to do this? How do you fail a test in Rust without doing an assertion? Is there just like a... I don't want to panic. So the problem is that what this ends up being is an instruction, and then we got to pull out the type. What if we can do assert? Can we do I? We can do a match statement, but I think there's an easier way to do this. Can I? basically we just have to do this. And then if it's not, then it fails. But is there like a macro to fail a test? There's not a fail macro, is there? I wonder if it makes sense for us to move this assertion effectively into here. Or if there's something else we should be doing here, rather. We don't get a fail, right? Is there a fail? I guess tell me this is not. Yeah. Assert. What is this? Use the tuple variant pattern instead of in. Do I have to do that, I guess? That's interesting. Wait, did I run the wrong test? Method not found. I'm not running that test though. Wait. I'm literally not running the test. Oh, I am running that test. What is it doing? All right. All right, so that's functional. Or we can do this. So it's none. We can do a panic and just say some, none, or I think this ends up being like what we want. Yeah, okay. So we can get rid of this now, basically. And then it's inst. Let's make sure that we're actually hitting these. I guess we know for sure we're hitting those. Because otherwise we're hitting either this or this one. So here's my other question then. If I do, like, can this be... Does that still work? So we'd want to have it return like some other type of, so we can have it return like a here, else turn some instruction there. This will fail our I think this will be like a 4, should be fine. Yep. And panic, we can put a format in there, but we can't. Oh, come on. Fuck. Cool. Yeah, that seems... This seems like the pattern that we want. Let's go back to here. All right. So let's go update all of our tests. Let's get rid of this for right now. And we're going to go clean up all these tests. We'll commit that. So this should be JN. It's -6. That should be JNZ. JLO. JC. And it's crazy how rusty you get just like not writing code for a long time. It's been, I don't know, months since I've written any like real Rust. After, I don't know, writing a significant amount of it. All right. So I think we're all good now. I want to run all the tests. All right. Give me a diff. Let's also get into a terminal. I don't think, yeah, I didn't set up any of the Git stuff on the Windows machine. Where did I put this? I think it's the source, users. Cool. All right. So we now have a instruction type that we can return into that can have more than just a jump instruction. Let's start working on parsing and decoding the single operand arithmetic instructions. So the way that we're doing this currently is we are using a bitwise AND with the mask, and we are masking off the top I don't know, like whatever that is. It might be easier to mask off the first 3 bits. So yeah, it's never a case where these are always 0, 0, 1, these are always 0, 0, 0, and these are always something else. All right, one sec. It's got to respond to this text. So it might make sense to start masking off just the first 3 bits and using that to determine like whether it's a single operand, a jump, or else we fall into here and we can just decode the opcode from it. I guess we can just leave it like this. This is the single operand 0, 0, 1. Things are not good. Why are things not good? Things are not good because we're not returning something. If we run this, do we still get all the tests passing? We do. All right. Jump. All right. We'll fix that later. Const single. And that's 0, 0, 0b, 0, 0, 0, 0, 0, 0, 0. I probably want to clean up some of this code a little bit. First 4 bytes or 4 bits. Check. Doesn't match a it doesn't match a single operand or jump instruction will fall through. Yeah, all right. So, int type mask. All right, let's make sure the test will pass. And let's save these changes. Factor instruction. Yeah, commit that. That's fine. So let's write a failing test, and let's get a single single operand arithmetic instruction to get decoded and fail. Ret I is going to be the easiest one of these to implement. Basically, we need this to be so 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0. So we're looking at 1, 3, 0, 0. So it'd be 0, 0, 1, 3, I think, for the actual test, because we have to do it in Little Endian. Ret I. What did we say that was? It was 0, 0, 1, 3. And we should be getting a single operand instruction. And we have no assertions to make here. So let's see if this succeeds. Were those the right order before? No, interesting. Oh, because I'm returning none. Right. I was right before. All right. So this is going to fail because we're not currently matching the app code. Let's find here. Yeah. So we are going to return none here for right now. But let opcode equal single operand mask and first word. Return the match. Opcode. None. And the opcode for this is going to be should we shift these? Maybe we should shift them. 6 bits over. It will just make it a little bit easier. So that ends up being 6. Some So I think this should correctly parse the right eye. Oh, we didn't define that yet. Single operand mask. We need 0 0 0 0 0 0 1 1 1 0 0 0 0. So that should give us the mask of the bits that we actually care about. It also might be time to start breaking some of these tests out, or some of the code out in other places. No instruction returned. So let's see what we're getting. Yeah, there we go. Opcode is 0. First word is 4864. Two has 6, just 2. It's easier to do this as so that's correct. 1 2 3 4 5 6. Yeah, so if we shift it 6, it should be inst type. How is inst type 0? Oh yeah, that's correct. But opcode. Opcode is 768. So 0 3 0 0 what does that look like? That looks like 4 0 0 1 1 and this is correct. So 1 2 3 4 1 2 3 4 2. Yeah. So that's correct. Now if we shift it, 1 2 3 4 5 6. Is it 7? Yeah, okay. Why is it still 0? What is it? Oh, I wonder if the order of precedence is wrong. This seems like it's a precedence issue. There we go. That's a precedence problem. So let's write some opcodes. Opcode. What is this? So this is 4 5. Push is 4. Shit, come on. Push, sign extend, code, RA, SWPB. RC code. We might want to make these 16s. So we might end up just cleaning some of this stuff up and not using constants for these. I don't know if it makes sense to do this, but like we can always go back. I trust the compiler to do a good job at like optimizing this for us. But just these look like a little bit easier for me to read. This also might end up being something where we do this same optimization we talked about doing here, where once we validate that the opcode is real, we can look it up and just create like a single one that has the correct instruction for it. So we're going to need to parse whether or not right, so these can either be byte or word, meaning that the value can either be byte or word. So the AS will tell us what the addressing mode is. So all those are 2 argument, none of them are 1. So like you can push a specific value. Sorry, I'm going to switch over to just webcam real quick while I log in. Because I do want to see what it assembles some of this stuff to. I think that it might help make sure that like we understand like what we're getting. So let's move this back. So like you can push 10. So if we look at this 3012, that ends up being and so if we go to push, so that doesn't seem, because it's backwards, that's why. 1230. This is the high byte. Some all right, so with push we have one, 0. Zero through. So the registers end up being 0. AS is the 4th and the 5th bit, so that ends up being 2 for the AS. So register indirect. Operand is in memory at the address held in Rn. That seems kind of weird. That seems kind of weird. Then the next bit is 1. The 1 means that what? So here, 1, 2, 0. So that's, oh, it's 2. It's 1, 1. So it's this. The part I don't get is so then AS is 1, 1. Okay, so because it's 0, the register is 0. So weird that it has 4 bits for the register here. Right. So, hey, Mr. Edmakes. So, these are our registers, and then and because this is 0, which registers 2. So yeah, so register 2 is SR, or the flags, and 3 is stack pointer, I think. We can check that really quick. So 0, 1, 2, 3, I think. So 1 is stack pointer, 2 is the flags, and 3 is CG, which I don't know what that is. So the addressing mode, enable other functionality. So we're talking about register 0, so it ends up using this addressing mode. So, and because we are 1, 1 here, or 3, it's going to be an immediate value. And then this will tell us how much, how big the next thing is. So if we do register 2 with mode 2 returns constant 4. With mode 2 returns constant 4. Right, okay. Yep, that makes sense. So we're probably going to figure out what register we're using, because that will determine the the addressing mode for the source. Register and this, we just need the last 4 bytes, for 4 bits. So the question that I have then is, if we go to assembler here, if I want to push B10, so it still puts in the it still pads everything out to be 16-bit no matter what. So we're always going to read a word worth. We're never going to read bytes. Is it this syntax? What is the syntax for oh, it's 0x, okay. Yeah, okay. Perfect. So we always read our second full word in. At least for this type, we always read a second full word in. All right, so we're gonna match on the register if it is 0. PC. If it's 2 or 1. Oh no, it's only for 2 and 3. Is that inclusive or not? S, R, and CG. Else. Addressing mode. So let's go fill some stuff in here. A single operand instruction, it's going to have a opcode. For now, we'll just do this. I think we're going to end up using like real constants. Later, or like an EM later, or something like that. But for now, this works fine. Snake case, you're right. So we're going to have an opcode. We're going to have operand width. U8 is fine. Opcode, operand width, addressing mode. And I think we'll probably end up changing this around a little bit, but indexed. Just through indirect auto increment. Label. Stuff right now. Immediate. Absolute. Constant. We may want to go a little more detailed for the constants here because these all have special meanings, but I don't know if we're going to care about capturing that here or if we'll encode it into something else. So let's start with 0. This is going to be like the most difficult for us to implement. Not difficult, but just like we're going to have to play around and figure out what we actually want for this. And figuring out whether or not we want to do a source addressing mode and a destination addressing mode, just to make sure that we only have like valid values. But I don't know if it matters or not. So if doing PC, basically we're going to match So we're gonna have to add like under our things here. I'm gonna panic for right now, but we're not gonna end up panicking. We're gonna bubble up like a none here eventually. So we just need to support, what is it? It's 1 and 3. It's 1, we're going to do addressing mode, and it's going to be symbolic. What did I call that? It wasn't. I didn't call it symbolic. It's not that. The operand is PC plus. And so is this a... Is this an I-16? Yeah, that would be an I-16, I believe. And then immediate... Oh, shit. So we're going to have to... Where does X come from with register AS? Are you talking about right here or right here? Register 0. Register 0. In the doc you have in the browser. So you're talking about X come from with register 0. Yeah, so X, so it says the operand is in memory at address PC plus X. So I would assume that it's the next word. So like you read the next word in, and then you take like PC plus that value, and it gives you the location in memory where it would be, but I'm not 100% sure. Yeah, I don't know. I haven't seen this code used before, so I'm not 100% sure. But that's what my assumption is. So I think for all of these, there's a word after every single one of these instructions. This is going to involve like a bunch of like ones complement math as well. So let's go ahead and read our next word here. Okay. Shouldn't need this anymore. I think we're just gonna reuse this. You know what? Maybe it's time to switch this out to take in just a like a big slice of all the data, rather than trying to work around the reader here. So the problem is, like, we're gonna have to keep doing all this, and it might just be easier to do this now. How much if we diffed? We've diffed a lot. Yeah. All right. Let's stash this. Let's not stash. Let's check out a branch. Parse single operand. All right, it's gonna go back to here. Let's rewrite this. Let's change the interface to this, and make this take, rather than a reader, we'll make it take a slice. I'm also getting to the point where I might want to move some of this code out into other files. But, all right. Do I just need a lifetime? No, I don't need lifetime. Okay. So we get to get rid of this. We get to get rid of this. We get to get rid of this. Data adder to so we're going to check to make sure that data len is greater than is less than none. And yeah, we're probably going to want to end up making this a result rather than option. Mismatched types. Fine, we'll make this a U16. Okay. Let's run the test. Oh. Slice indices are of U size or ranges of U size. Maybe they should be U size then. What? Oh, this needs to take an array though. I think. I don't quite understand the error here. So, all right, we also don't need this anymore. That can go away. Slice indices are of type usize or ranges of usize, but they need to be also these need to all change. And they don't need to be mutable anymore either. Yeah. So, a little bit of work, but not, I don't think this will be too bad. I think rebase this is going to be kind of bad, though. All right. Cannot be indexed. It's not just that, is it? Slice indices. Oh. I don't think that this will work. I don't think this is possible. So what is, this takes. No, that's not what I wanted. Take me to the definition of this. Yeah, so this takes an array of 2 U8s. I don't want the allocation. Will this work? So like we could do something like this, like data iter, like skip, adder, collect, I just gonna want this to be like a usize. Like we could theoretically do this, I think. Take 2. It's a copy type though. I don't understand why that wouldn't be able to So the problem with doing this though is that this is gonna I think this is gonna literally iterate the address size every time, which means it's like super inefficient. Like, and because it's an array or a slice, like we have random access. Like this isn't really what we want to be doing. Rust. I could do try into, or maybe into. Oh, I wonder if that does work. Can we do data adder plus 2. Does that work? I guess, can I not index by U16? So we could implement from for it, and that would give us what we needed. I wonder if this is going to have the same problems before because it's so I could do 2owned, and that'll create us what is this? But it ends up being a vector. So it's not able to coerce. Not coerce. It's not able to. I just don't understand why. Like U8 should be copy. When starting with a slice rather than an array, fallible conversion APIs can be used. Interesting. Okay. So we do need trying to convert. Invites rest. What is okay, so it ends up being I don't care about input. So it'd be data split. Trying to What does this do? The standard mem size up. So method not found in U8. No method split at found for U8 in current scope. Does it need to be mutable? Is that the problem? I don't want that to have to be the case. So that's it should be a oh. There. So I don't think we have to worry about unwrap failing here. As long as there's 2 bytes of data, like it should be able to convert into that. We're doing all these tests. These all succeed. All right. Did it run? Past, okay. To slice. Commit. All right, so let's see if we can rebase this now. So this is gonna be a mess. So get rid of this. All right. Can we get default on this for now? Oops. All right. Yeah, so register doesn't exist. That can be a U8. Where is that? All these can be a U8 for right now. Probably switch these over to real register enum rather than numbers, but you know, it doesn't really matter right now. I16. We'll call this a U8 for right now, just because I don't have a better value to stick in there. Oh shit. Oh yeah, and then we can do this. this ends up being decode. Oh, god damn it, I just keep hitting that button. And this gets to be that. Addressing mode does not have debug. Debug clone. And partially Q. Default. I'll probably get rid of these defaults once we go in and like actually fix all these things. Default cannot be derived from enums. Oh. Fine. Then you know what? We'll get rid of it here. We're just gonna say it's empty for right now. We don't need values. Expected an array of U8, and instead it found a tuple. Interesting. Oh, because I didn't do the split at. All right. Because we don't have data here. Um, 10 or 16. All right. Oh, we have it working. Oh. All right. Stand up for a minute. Drink some water. So, yeah, that refactor made it a lot easier. Now, I mean, I know that we're gonna end up having to use this when we go to Binary Ninja. So, I mean, it made sense to do it now. It's unfortunate that we can't pass it a reader and like basically make the parser streaming, but it is what it is. Maybe we can find a way to do that. And honestly, like the firmware for these things, it's gonna be at most like U16 max bytes. So it's not like it's the end of the world. Like I think like every modern computer can pretty much like hold that like no problem. Get rebase. Added that. Yeah, get rebase. All right. Perfect. Yeah, so we're getting pretty big here now. This is at like 300 lines. Probably do want to start cleaning some of this up. Maybe it makes sense to do some of the decoding for this stuff first and then do the refactoring, but I guess we can get to the point where we can get a ret I decoded, and once we have a ret I decoded, maybe that's like a good point to do it. A bunch of the error handling still has to get cleaned up. We're going to end up turning this into a result, I think, rather than an option. Maybe we'll make it return a result of an option. So, I don't know. I guess an error could just be a decode failure as well as, like, you know, any of these other error types, like, you know, presumably, like, if we do need to handle this, I'm kind of curious if there's a way that we could avoid having to do this, because, like, we can just assert that there's always going to be enough bytes there to do it. But like, for right now, this seems to work. Some of the masking I also might want to end up changing. I don't know if it's like, if it makes sense to, like, do it. It's getting all over the place, and some of this is, like, getting kind of gross. But we're tested. We can refactor, and when we do, we know when things break. Give me a second. I'm gonna put some music on, which I'm sorry I can't play over the stream, but everything goes onto YouTube for archive, and I don't want the audio to basically get, like, killed. So fortunately, you don't get any of the music. So let's go back to here. The next step is going to be bringing back in the data here, so that we can start populating this into our single operand instructions. We are going to have to do some ones complement stuff, which maybe it makes sense then to convert that, to build a conversion function now. And so these are easier than we had last time. Hey, Pataroko. I'm not sure what language that is, but welcome. So like I said, these are easier to do ones complement for than the weird stuff we had to do up here, and that's because these were 10-bit numbers rather than 16-bit numbers. But since we're reading in the full 16-bit number, we get to just do a bit flip here. And return it. In fact, I'll just make a function. Is it I am? Yeah. gate. Expected. Word. One's complement is x XOR. Oh, you're right. I wonder if the compiler pass would have figured that out for me. What's the XOR operation? Is it caret in Rust? Yeah, it's caret. Okay. We probably still want the function rather than this. Why? You still need to do the check though, right? Or do you not? I guess you don't, because say we had like I don't know, 9 or -9. So this would be 9. So that's 9. That's -9. Can you do the XOR no matter what? So you end up getting no, so you can't do it because you'd end up flipping your high nibble. So here you get 0, 0, 0, 0, 1, 0, 0, 1. And so yeah, that works. So yeah, you still need to do the check. we were going to do a ret I before we started going down like all of this. Ret I is wait. Does it have two instructions? Two following words? Oh, weird. Right, because it's popping off the stack, so you're never gonna... Is this the only instruction in this type that doesn't have a second word? Call is gonna have a second word. Push will have a second word. Oh, maybe they won't. It may only have a word if it's so if you do like push R9, it's only a single word, but if you do push 10, you get two words. So we're not going to want to read this until we know what the addressing mode is, because the addressing mode is going to determine whether or not there's a second word available. Which makes sense. All right, so word. So basically, it looks like there should be like a second word here, a second word here, and then these should not, but this one, yes. So like, to like R9. Yeah, so that ends up cool. Okay. So we're going to match on the register. If it's, let's go back to here. If it's 0, which it's going to be for ret I, then we're going to match on the address source. So here it's going to be 1 1. Okay, so then it's symbolic, and we said that symbolic is an I16. So in this case, we're going to need to read okay. So then an immediate opcode addressing mode and then operand. We'll just put that 0 for right now. Oh, that's interesting though. So we need to check the operand width before we go to here and figure out if we need to do and so they can have an where is that? Where do we define this? This is some Oh, not sum. It's option. Is greater than 0. None. So we have some errors still down here. I think we can basically just do none here. This gets to be that. Addressing mode. Yeah, these need to be some. And then red I, like this should just succeed. Second word. Exclusive range pattern. Is inclusive range pattern? The special ones were what, 2 and 3? Yeah, so that's inclusive. So invalid addressing mode. Why is our addressing mode invalid? Because we're not shifting it. No, we shouldn't have to. We match on register. And our source. Yeah, so source needs to get moved over. The source is 4. Operand width. Oh, interesting. 0 means it's 16-bit. So this is probably gonna succeed, but not the right reason. For include, interesting. 5. No, it should be 4. That's irritating. That, I mean, I guess I understand why they packed it that way, but it's interesting that these are special cases. So where BW is going to be either set or unset for byte or word. There's also some that are strictly just 0, which means like the width is 0. So we're going to have to add in special case handling for that. It might have been easier to start with these ones instead, just because there's going to be a lot of special cases. But we might need to restructure the code somewhat. Based on, and do it by opcode instead. Because each opcode is going to have like some of its own handling, it looks like. Which is fine. Yeah, seriously. I mean, you know what though? Like, I'd still much rather be writing a disassembler for MSP430 than, like, say, a disassembler for like Intel, or a disassembler for like PIC or AVR. Like, this is still significantly easier than anything like that. I mean, like, there's what, like 20 something instructions here. Everything's word packed. Like, Intel is fucking awful. Just having to figure out like how many bytes wide an instruction is. So yeah, I think the move ends up being we base it on the opcode, and which we're already doing here, and that makes it probably more correct as well. I feel like we're duplicating code here, but maybe that's not as big of a deal, or we can turn it into functions and make the handling a little bit easier. We'll figure that out in a second. I do want to figure out why the The source is wrong, though. Oh, again, it's precedence. I'm an idiot. It's operator precedence. And the operator width, that'll be 5. It's still invalid. Opcode is 6. Register is 0. Source is 0. Operand width is 0. What am I? Yeah. So why does it think? Is this in the wrong spot? Also, oh, it is getting rid of this guy. Our source. Oh yeah, because it's either 1 or 3, and in this case it is 0. That makes sense. Okay. And that thing we just changed was the addressing mode. Yeah. Yeah. Okay. So that works. We're now getting like the correct value. It looks like for ret I, but I think we're gonna end up refactoring this. Let me commit this first of all. Yeah, I can enlarge it. I think, let me just do this. This works for ret I, but logic is incorrect for operand. BW bit. push. I'm getting real paranoid about like pushing all the work up now. I lost a bunch of like basically everything that I did from microcorruption. Actually, there's no spoilers here. All the work I did documenting all the levels of microcorruption, like along like the streams, I lost somehow. I don't know how, but I overwrote it, and so I've going back to like, the videos and like writing it back down from the videos so I can go through it again. So I'm like real paranoid now that I'm gonna lose more data on here, and I'm not sure if WSL had an issue or if there was something else, but. Is this better in terms of the amount of code? I know this isn't like super ideal. This is one of the unfortunate like side effects of you know, a big IDE that like has a whole bunch of stuff taking up space. Cool. Let's see if we can get like a quick like refactor in here. Yeah, this will end up being more correct just because the addressing modes are going to be specific to the individual instruction. So, yeah, we'll get a little bit better parsing, I guess. I guess I'll leave that there for right now because we're going to end up changing stuff. I'm going to bring this up here. I guess I can just keep down here. And operand width. And we figured it out? Yeah, we do. Expected to U8 and we got a 16. Yeah, okay. I think we have to wrap this. There we go. So for a call, maybe the move is we turn this into a function. And we pass some additional information in. call subroutine. Oh, wait, what? So this is interesting. So call definitely takes something else. Maybe I was wrong about. So ret I is a special case maybe, but like if you do call R9, it's not gonna have another byte. But if you do call like 16, that has a byte. Oh. That's how you determine it, is register direct, the operand is the contents of Rn, I think. Because the addressing mode is 0. So maybe we can do this. And so do you... In this case, the register is... Yeah, but so then why... How does this decode properly? So in this case, the register is 0, which means it's PC, and it should be using this. And the AS is 0, which isn't a valid AS. Unless R0 isn't actually PC. Wait, but... Oh, weird. Is ret I just a special case? Or I wonder if... So maybe this is right then. So this would be for this. And I guess we can implement this. Use dot dot equals. So there's a special case which is 0, which addressing mode sum register direct. And then so 1 to 3 operand is in memory at address held by Rn. So 1 is the only one that one requires an additional byte. kind of curious what happens to start getting these bad values. I'm probably going to want to make some like invalid instructions to actually test some of this stuff. So for indexed, we actually do need to read so then addressing mode 1 is indexed. Oh, it ends up being U16. It is up here, or I16. U8 and I16. Do I need to pass in the tuple here? Or is that implicit? Register. Two. Register indirect. Register. So we should be able to do like a call R9 right now. 8, 9, like 1, 2. This was 8, 9, 1, 2. And this should be a call. Okay, and in here, we should be able to verify that inst opcode equals call opcode. Call is going to be 16. Addressing mode is addressing mode. Register to it's register direct. Yeah, register direct. It failed. It got none. $12, $9, 4. So that's correct. And 0, 0, 1, 0, 1, 0. AS should be 0, 0 for direct. And then the register is 9. So why did that decode incorrectly? Source. That's I've got to go in a few minutes, but I think we can maybe figure this out and get it working at least for that. So we think we should be in here, but we're not. We're either here, here, or here. or we're here. Is our AS 0? AS is bits 5 and 4. So yeah, we're gonna be there. No, so register. This is wrong. That was the right thing. So now we're not handling this set right here, but we are handling these, and we're handling these. Yeah. Cool. So we're mostly decoding these correctly now. Make sure all of these tests run. Cool. Yeah, so I need to take off for the night. Well, at least a little while. Maybe we'll come back tomorrow or later tonight. We got a bunch done today, a bunch of refactoring. We're not quite done with all of these single operand arithmetic, but I think the next time we'll probably try to finish those up and add a ton more tests. I'm also not 100% sure that our logic here is all correct, but we'll verify that as well. And then probably do a bunch of refactoring. This code's like pretty messy, and I think it's time to kind of get it split up across files and get it cleaned up and make it a little bit easier to work on. Like right now, it's not. So I'm gonna go ahead and just commit ormat. Call. Anyway, have a good night. I'll see you next time. Hope y'all learned something. And if you want to go along with this, the code is all available here. See you all next time. Have a good night.